right as I'm about to start talking.
Every time you're ready to go.
Yeah.
Swarm comes in.
Alrighty, as the last of you all trickle in. Is it working? Is it on? There we go. Seems like it's picking me up. All right, cool. Our next speaker doesn't even have a bio for me to pretend to read, so our next speaker will just be Andrew Fox.
Hello, everyone. I hope you're having a great day so far. So far, I've enjoyed the heck out of this, so this has been amazing. So today, what I'm going to be talking about is open source 5G network deployment. And this is something that I have been doing research on for about 2 or 3 years now. And let's get right into it. So a little bit about me, just really quickly. I am a recent graduate of SUNY Polytechnic Institute. I have my bachelor's in network and computer security. While I was at school, I was doing research on 5G networks for about 3 years with one of my professors. And during that research, I made about 2 publications, which are available on Google Scholar. If interested, it covers kind of the same thing that we're covering today. So yeah, that's a little bit about me. So 5G. 5G is the 5th generation of mobile networks. I know this is basic knowledge. I want to cover it. Compared to 4G, there is a 100 times traffic increase. And 5G is in high demand because of its high bandwidth performance and speeds. Everyone seems to need that nowadays, especially in this fast-moving world. We all need high bandwidth performance for our networks when we're traveling and things like that. So yeah, that's a little bit about 5G. So how we're going to make this 5G simulation or deployment happen is there's a collection of open source tools. We call this OpenAI Cellular. They basically did research on a bunch of open source tools that are out there and kind of put them together and made it so they can basically simulate a 5G network right from your own device. And this could be a laptop, it could be servers, it could be pretty much anything. As long as you have Ubuntu as an operating system, you can run a 5G network right from your device. So that's pretty cool. And their main focus is on the research and development on AI-enabled cellular networks. So that's kind of their main goal. They want people to be able to experiment with networks while it's all open source. So if you have an idea of something you would like to try to run in a 5G network, this is the perfect platform to try and do that. So some of the goals of my project that I was doing was we want to install and deploy OpenAI Cellular. That process takes a little bit of time. If you were at my training yesterday when I was helping people set this up, it took a little bit to get the installation going. So installing and deploying OpenAI Cellular, running different components that go into OpenAI Cellular, which I will cover in a minute. I'll go over those components. A denial of service attack against this network. When I was doing my research, I was trying to figure out what I can do with this network. I mean, it's open source. You're running your own network. What can you do? And I thought, you know what would be interesting? I want to see if I can just completely take this network down and run a denial of service attack against it and see basically what would happen. And I'll go over how I did that and some of the results of that. And then also I'll go into some other projects and experiments that maybe you guys can try out if you're interested, and things that I didn't have enough time to try out, but maybe you guys can. So those are some of the goals of the project. So some of the technologies that go into OpenAI Cellular include Docker and Kubernetes. Those are really part of the containerization of the different tools and software that we're going to be using. We're kind of having them all separated in their own separate containers. Helm is going to be responsible for the managing of the packages that are all involved. we need them all kind of logged in one place, and that's pretty much what Helm is responsible for. And then the SRS RAM project, that's really the simulation part. When you put all these things together, they focus on how do we actually get this network up and running once we have everything all together. So that's kind of what SRS RAM project is all about, putting everything together and making that network run. So if you're interested, I would take a photo of this. This is a link to information on how to install OpenAI Cellular. It gives you very detailed instructions on how to do it. And you might, sometimes there's a few issues here and there, but I definitely recommend you guys check out their GitHub page as well. They have additional projects that go along with these OpenAI Cellular basically. So I would definitely check those out. So there are three main components that go into OpenAI Cellular. So the first one here on the left is what we call the EPC. It's essentially the logs for our network once we get it up and running. That's the first thing that we start. We want to have our logs ready to go once we have everything all set up. And it provides us with some useful information. I know it's kind of hard to see, but it gives us some information such as when things are being attached, unattached, tells you when services are being initialized, and some other things, setup request, and things of that nature. So it basically is just logging everything for us, keeping everything under control, and if something happens, that's very useful for us. On the right side of the slide, you will see the G node B, or essentially what is the cell tower that we're going to be simulating. And this terminal window also has some very important information for us. I'm going to zoom in on this picture a little bit. It tells you when users are connecting, disconnecting to our cell tower, and it also provides us with some other information, kind of like handshake agreements for when the phones are connecting to the cell tower and things like that. It tells us all of those things. And then our last component that goes into OpenAI Cellular is, of course, the most important part, your phone. The phone that's going to be connecting to the cell tower. And this also will provide us some information. It tells us the IP address of the phone once it connects to the cell tower, and it gives us other information, sample rate, what cell we're going to be connected to, and what other services are running on your phone while you're connecting to the cell tower. So there's a lot that goes into running all this, a lot of components that go into it. So I highly recommend looking deep into the documentation. There's so much that goes into this that I can't fit it all in 25 minutes. So yeah, that's kind of the main components that go into this. So when I was running this denial of service attack, I wanted to collect information about what was going on during that time. So I collected a few metrics while I was running this attack. I wanted to see if I can really break this thing. Unfortunately, it did not. It actually handled it pretty well, so that was pretty cool to see. So what I decided to do is I ran just the regular network, the connection, the cell tower, the phone, everything connected for about 2 hours or so. And basically I collected the bit rate information of how the network was performing for the 2 hours. And then I stopped it. I ran it again, but this time under a denial of service attack. And it's kind of hard to see, but there's kind of a slight decrease in the bit rate over time. I know the graphs don't really, I guess you can kind of see it a little bit further down. So it handled it pretty well. But I will say, though, with the denial of service attack, there's lots of spikes that go down throughout the 2 hours. So definitely it did have some impact, but obviously it was still up and going through the 2 hours. So, but again, very interesting to see happen in real time and mess around with it and just see what would happen. And another metric that I collected was ping response time. I decided to essentially ping the cell tower for 2 hours along with collecting the bit rate. And same thing, run it normally for 2 hours, run a denial of service for 2 hours. And as you can see, there were some large spikes that were going on during this attack, and at some points even going above 750 millisecond response times. So there is definitely an impact on ping response time throughout that attack. So that was very interesting to see. So some other projects that we can get into, they offer a feature where you can do network slicing with 5G. So essentially, if you want to set it up so, for example, let's say we're running a business and we have certain users that we don't want basically talking to each other on that network. So we can essentially just split up the network, have our regular employees on this part of our 5G network, have a part of, HR on this part of the network, essentially just splitting it up for us. So it's interesting to see how that process goes along while you are running that. So they have instructions on that on the website as well. And I think that's pretty cool that you can mess around with it. And you can set it up to do as many slices as you want. You can do like 1,000 slices and have the worst, bit rate of all time. Yeah, it's pretty cool. And then also they have a testing platform where actually you can run your own code essentially, and you can run it within the network and see what happens. So this picture kind of shows you what the testing platform looks like. There's going to be an actor, which is going to be the cell tower or device, and you can basically upload your script or code or whatever you have onto it, and it will collect metrics for you. For my experiment, I figured it would just be easier to collect that information and put it in like a spreadsheet and do that, but they have the option where it will create the graphs for you in the end. And you can collect basically a bunch of different metrics that you want. You can set up your own custom metrics, which I think is really, really cool. And also it provides you with logs of what's happening while you're running these things. And it's a really, really awesome collection of tools that you can use to run your own 5G network right from your device. So let's see. I'm going to really quickly pull up a video of kind of the installation process, so you guys can get an idea of how this process works. So let's see. So there's different parts that go into this. Okay, give me 1 second. Okay, so the first part is running the EPC through. So basically, each of the components are going to be running on different terminal windows. So what I do is I have maybe about 6 or 7 different terminal windows open on Ubuntu, and I have everything all ready to go. So on the website, it tells you exactly what to put in on each terminal. So for this first one, we're essentially setting up the EPC to run, which again is our logs for our network. And then once we have our EPC, I'm copying over that so it can set up the EPC. And then next we have our gnodeb, which we have to export some information before running that command to get that up and running. It needs some additional information. So I'm copying that, put that there. And then last but not least, the user equipment after this, that's going to be, again, in a separate terminal. So there I'm setting up the user equipment. Now, this next part, what we want to do is, while this network is running, we essentially want to be sending traffic within the network to make sure that everything is running correctly. So on this first terminal window, what I'm doing here is we're setting up a server-side connection where, and basically the output of that I'm putting into a text file, so I have that output so I can use it, make graphs and things like that. So that's what I'm doing in this one terminal here. And then in the next one, we're going to have it from the user equipment side. And we're going to have, again, I want to collect that information. So I'm putting it in a text file for me, so I have it on the side. And then we're ready to go. What I like to do is I like to have everything set up and all ready to go in each terminal, so I can just go, okay, this terminal is running, okay, let's move on to the next one until all of them are connected. And then also, if you want to collect ping response time, which that's what I'm doing here, I'm pinging the cell tower in this scenario. So that's essentially what I'm doing there. And hold on, so here is where I actually get the 5G network up and running. So first, the EPC. I'm going to hit enter, and then that's what it shows up at first when you first run it. Now, what it wants us to do is it's waiting for us to start up the cell tower. So here we are going to run our GNOB or the cell tower. And sometimes this takes a second for a connection to be made to the logs. And in this terminal window, now I'm running the user equipment. So in a second, it's going to assign an IP address to the user equipment. And we'll see that happen in real time. It'll say, hey, this is the IP address of the user equipment. Sometimes it takes a second. Okay, so I paused it. It says a found cell. And it tells us that a connection has been made, and this is the user equipment here. So it's saying a connection has been made to the cell tower. It tells you the sample rate, and it's, hold on, go back 1 second. When the user is connected, it also will say that in the GNode B, it'll say, hey, this user just connected to our cell tower. So that's essentially what that's going to do. And now what I'm going to do is I'm going to be running traffic on the network in these two terminals to make sure that everything is running correctly. And as you can see, there's responses. So that means that traffic is being sent between the cell tower and the user equipment, which is exactly what we want. And essentially you have your 5G network running on your device. So, and again, there's a testing platform that you can utilize with this to collect even more information. And yeah, this is a really cool collection of open source tools. And I hope you guys really get to test it out, try it on your own, see what you can do with it, be creative, come up with something. Yeah, basically, and if you want to connect with me, I am free to ask, any questions, send me an email. I'm here to help you guys, and I really appreciate the time, guys. Thank you so much. Does anyone have any questions? Yes.
Did you take that picture this morning?
No, this is actually, no. Oh, yeah, that's a good point. No, I didn't take that this morning. This was when I was at my school, last week of school. And I didn't plan that, I promise you, but that was good, Any more questions? Yes.
Do you know if this toolkit OAIC can be used with hardware simulation as well, like the low power transmitters?
That's a great question. Actually, so on their website, they actually have a list of the exact equipment that they used. So this can be implemented with, hardware. It's a little pricey, but you can buy alternative, cheaper equipment for that. And yeah, you can have that running right from your house. You just set it up. Yeah, and all the instructions are right on their website, so you can set that up. So if you're actually going to be using the real equipment, yes, you do have to. There's a whole process for that. But if you're just running it right from your computer, like I did, there's absolutely no problem. This is all virtualized. It's all right on your computer, so no worries about that. But hardware, do worry about that. And Any other questions? Yes.
Can you simulate like LoRaWAN devices with this?
Can you simulate what?
LoRaWAN-based devices?
Yes, actually, yeah, you can. There's instructions for that on their website as well. It's all right there. Yes, but they do. Yep. Any other question? Yes.
What would be the consequences if I did that, like with the hardware?
Well, okay. Maybe. Yeah, you want to make sure that you're not interfering with any other devices that are in the area. There's a whole process of things that you have to do before you do that. Yeah, that's all I'll say about that.
So to give you an idea, every piece of spectrum in every country is managed by the Federal Communications Commission of that country. So even if you weren't in the US, you would need to get a license to transmit on those frequencies to do it legally. And then if you were caught doing it illegally, I think the fairly standard fine from the FCC is $10,000 a day for every instance of whatever you're doing wrong. And then they would have a long talk with you if you ever showed up. And for some frequency bands in the United States, they won't necessarily come after you for violating it because you're not really impacting anybody's business to do it. This, you would be impacting Verizon, T-Mobile, AT&T, Nextel.
Yeah. So please be careful. Please, I do not take responsibility for what you guys do with this. Please. Okay. But yeah, any other questions? And again, if questions come up later, you can always email me. I'm available, and connect with me on LinkedIn, all that stuff. Okay? All right.
If you were doing it quietly in your basement, the range is just inside that room, no one would even know you're doing it. So
Yes.
Right.
Maybe you should just do ham radio.
Yeah. Right.
The one thing that I wasn't gonna say ham radio, but amateur radio overlaps on some of those bands
Right.
that they transmit on
Right.
as the secondary user. And under your amateur call, you wouldn't be able to encrypt it, but you would still be able to use it. We just have to make sure the technician license gives you rights to frequencies and bands from basically 50 megahertz up to 475 gigahertz, and anything above 475 gigahertz is free for everybody to use. But I'm saying nobody's using that right now.
Right.
Most of this stuff in 5G is, the reason why you can't really use an SDR for it is the low end is like 6 gigahertz, and there's a 10 gigahertz band, and you might be able to use some of those frequencies if it's like a down converter.
Yeah.
You still have to have the equipment that transmits on those frequencies.
And also, I will say on their website, you can reach out to the people who are part of the development. They're very nice, and they can help you guys with setting up actual hardware if you want to do that. They're the perfect people to ask about that. Yeah, any other questions? No? All right. Thank you guys so much. I really appreciate it.